Going outside and collecting my data from the Bluebird. I again used my VNC to transfer my pictures to my computer. So what I did was I got to my VNC, connected to my Raspberry Pi locally. I mean, through internet or through hotspot or through Wi-Fi, and then I used the file transfer from option from VNC, and then basically downloaded those folders from the online uploaded website to my computer. So after downloading those pictures, I closed my VNC and now I've put them in the right place. So as you can see here, let me just show you one for example. Here's one good example of scanning the Bluebird. So I have an image here, and then it correctly shows that this is the right image and this is the right folder. Again, I use the data generation file. So what I do for the data generation file is again I open it through my terminal. So basically, what I do is go ahead and then just change the folder into the right folder in the array. This Python file runs over all of the loops over all of the images, and then it assigns the coordinate points into a text file. So as you can see here, um, I have the name of the folder indicated here as image A, so I can change that or to the right folder, but basically I have correct into image A, and then that goes through that image and then finds the text file and then assigns the points there. So basically, it goes through this folder and then it assigns the text file into test A, or I've also created another one where I kind of try to filter the outlying images so I can get my point cloud. So once I get my text file, as you can see here, um, you can see that all of my points are here, and then I can scroll down to see all of my values. So these are the points that are recorded in the text file that the Python file is getting from the images, and then the HSV or masked images, because I used HSV to just pick out the line from this image. So once I mask my images and then run the Python file, I have my points, and now I can go to MATLAB and then run that text file to generate my 3D plot. So if I run it, it should give me two figures. So one would be the multicolor one that has more information, and then one is the basic one. So as you can see, the red dot here is where my camera, where my Pi camera is. So if I rotate it a little bit, you'll see that this kind of looks like a bird, and it was trying to map all of the projected lasers, which is why it's kind of diagonal. And I can, zoom in and then see what it looks like. So this basically tells me, how far away my Raspberry Pi camera was from um, the uh, the statue. So these are the numbers right here. Try to indicate it in inches how far away the statue is, and then this other figure tries to show and demonstrate how the brightness levels of the line laser was evident in the um, point cloud generation and the line scanning and point cloud generation. So I'm gonna, as I rotate it, you'll basically see because the lines basically converge to the camera, which is why you have the points right here. So if I turn it around, you'll see what it kind of looks like, the bird. And it was very difficult to get the line in on the neck, and as it got into the head, it was very hard to mask it, which is why you don't see lines around the neck. But from the all other data or points collected, you can basically make that compare. Um, so you can see that it's very close to the bird image. You can see the beak. You can see the beak here. You can see the talons and the feet. So yeah, so you collect the image, you transfer the image, you mask the image, you run it through Python, and you collect your points, and then you basically run it through MATLAB. So this is the point cloud generation for my Bluebird, which is my project for this class. And thank you.